So this talk is really about discussing all the interests surrounding cysteine, glutathione, immunity, and there's been a huge amount of hype in the news, in the natural health industry around the world surrounding this topic, and that's really to do with some of the legislative changes that have been occurring here in New Zealand and around the world with organisations like MedSafe and the FDA changing the regulations surrounding particularly NAC. So we're going to talk a little bit about that tonight and what that means and why and what's going on. But the discussion really is around immunity, and it's really around what we can do to support our immune system. So I've been working with glutathione for many, many years. I did my PhD in medicinal chemistry, and the area of interest of research for me is around selenium, sulfur, glutathione, cysteine, and how all of this works when it comes to chronic inflammation, chronic stress, and now also with immunity. And that's why I'm really passionate about this topic, because it's something very close to my heart when it comes to a research perspective. But for most of you out there, you probably haven't even heard of glutathione. Maybe up until the last, I don't know, 6 to 12 months, no one had heard of NAC, no one had really heard of cysteine. But we've been preaching glutathione, cysteine for many, many years, because we know in terms of biochemistry how important these molecules are for our body and our immune system when it comes to stress and chronic inflammation. So let's get started on this. The immune system is made up of two key components, and I've tried to break this down in a really sort of simple way for you guys to understand. So we have what we call the innate immune system, and then we have the adaptive immune system. So the innate immune system is what kicks in straight away. And this part of our immune system, I liken it to being like the infantry in the army. When our body is under attack, the innate immune system are the guys that go in there straight away, all guns blazing, and try and destroy whatever is foreign to the body. So we have these cells that are part of that, like the basophils, the neutrophils, and these types of cells that are there to create inflammation and to try and destroy whatever is invading us. And then over time, the body begins to work out what this invader is, and then it starts to become more strategic. And that strategic part of the immune response is what we call adaptive immunity. So that's where we start to develop things like antibodies. And I liken the adaptive immune system to being like the headquarters of the army, where they sit down and they start to figure out, who are we dealing with here? What is this invader? And how can we more strategically attack them, as opposed to just going in and bombarding them with everything that we got. So adaptive immunity is obviously key to the long-term sort of immune response that our body wants. But the initial immune response, the innate immune response, is what's really, really important, because the way in which our innate immune system reacts can determine how badly affected we will be through a viral infection. So the ammunition that we use in this kind of attack when we get a virus or a pathogen coming into our body is in the form of what we call a reactive oxygen species or a reactive nitrogen species. And the cells that specialize in this, things like macrophages, they're amazing at producing huge amounts of these types of really reactive oxygen species that can destroy cells. So to give you one example, we have an incredible cell called a macrophage, and the macrophage has an enzyme in it called myeloperoxidase, we call MPO. Myeloperoxidase literally makes bleach inside of our body to kill an invading virus or bacteria. And so, we use bleach to clean our toilets, we use bleach to mop our floors because it kills everything. Well, we actually make bleach on a little micro scale inside these macrophage cells. So the macrophages, they will engulf the virus, and then they will turn on that bleach making system, and myeloperoxidase will start pumping out bleach. And this is amazing because it can destroy that virus instantly almost. But the problem with this with this response, this innate immune response, is that when our immune system fires up, often like what we see happen in, in a warlike setting is we get collateral damage happening. Yes, you may be destroying the enemy, but you're also destroying everything around it. And this can be a really big problem because around these areas where we get these viral infections, we have a lot of very special tissue that's very, very important. A lot of vascular tissue, for example, the blood vessels and cells. And this is what we see with some of the issues with things like COVID, is that the innate immune response and the collateral damage that's occurring is what's creating all of the problem. So we're not just destroying the virus, but we're also destroying our own blood vessels. We basically put a shield up in our body, and the shield is there to try and protect those cells that are going to be in the way of the fight. We also have ways that we can repair damaged cells and damaged tissues. So they're like the Red Cross for us. And where do we get these kinds of molecules from? Well, we get them from food, which is why food is so incredibly important when it comes to immunity. It's why we eat oranges for the, the vitamin C, the ascorbate, because ascorbate is an incredible molecule to protect our body. Why we eat things like cacao and maca, because they're rich in polyphenols. Why we take grapeseed extract for resveratrol, blueberries for anthocyanins, green tea for flavonoids. These are all molecules that can go to help protect our cells. They are shields, so that when we have inflammation occurring, those molecules will take that damage on our behalf and protect our cells. So we know that food is incredibly important, and you guys out there, I'm sure, are eating the right foods and doing the right things when it comes to our immune system. But let's look at the next level of defense, and what I call the really specific line of defense being enzymes. So enzymes are big, complex proteins that are specifically designed through our DNA and coded for to do jobs in this area of protection. Now, the main enzymes that are involved in protecting us during an infection when it comes to the innate immune response are enzymes like superoxide dismutase, catalase, glutathione peroxidase, the peroxyredoxins, the thioredoxins, and glutathione comes under that area as well. And all of these enzymes have some special things in common. They're proteins, so they're big, complex structures. They're very specific to specific tissue and cells. They have a very specific job. So for example, superoxide dismutase, its only role is to remove that reactive oxygen species called superoxide. Now, this study here that I put up was a study that we did back in 2008, and we looked at the protective ability of these kinds of molecules. So how good are the shields? How good are the Red Cross at getting in there and protecting us and stopping this collateral damage? And we looked at the factors that were involved in this kind of protection. And it came down to three key things. Number one being the availability and concentration of these enzymes. Are they in the right place at the right time? Number two, how easily and quickly they could recycle and reuse themselves. And number three, what we found the most important of all was how fast they were at reacting. What is the speed in which they can get into that site and protect us from those tanks and those guns blazing? So those were the three key factors. And here's something amazing, and this is what amazed me, and why people sometimes say, why is your company called Seleno Health? And the answer to that is because selenium, in chemical terms, we call seleno. And selenium was the most incredible atom and molecule with its ability to protect our body. And I found it so fascinating and amazing as an element. For me, selenium epitomizes the natural immune and defense response of the body. So I named my company Seleno Health, because if you have selenium in your body, you will be healthy. Now, the enzyme in which selenium is involved in is called glutathione peroxidase, GPx. And what we showed in this study using what we call chemical kinetics is that GPx, the enzyme, can react 200 times faster than some of those other food-based antioxidants. And this is phenomenal when it comes to speed. So when we looked at people with chronic inflammation, chronic health conditions, GPx was an incredible marker along with glutathione, and I'll explain why glutathione shortly, but it's to do with the way in which the enzyme works. So what we were able to show was that these kinds of speeds of reaction would determine how effective this antioxidant was going to be and how much it could assist us with reducing down inflammation during, with cardiometabolic disease, during infection, those types of things. And here's some other interesting statistics. So let's look at some of these antioxidants. I've got the molecules here on the right. We've got resveratrol here. Now, the circle that I've circled is the active site. So when we talk about the shield, those guys that were holding the shields, the shield is the active site, the part of the molecule that's reacting to protect us. So resveratrol's shield is this oxygen here, this hydroxyl group, we call it. If we look at ascorbate, vitamin C, it's again this oxygen here. And when we look at glutathione, the shield component of glutathione is actually a sulfur atom. And if we go to GPx, which is glutathione peroxidase, it's a selenium atom. So what we mapped and what we understood was that the speed of the antioxidant was incredibly important. But that speed was directly linked to the active site of the shield and the site that was reacting. And when we look at this on a periodic table, and I'm sorry to pull out, it's probably been many years since you've seen a periodic table, you see here oxygen, selenium, and sulfur all sit in the same group. They have similar reactivity. But as you go down that periodic table from oxygen to sulfur to selenium, the activity of that atom massively increases. And like I said here, we've gone from oxygen to sulfur, which is 20 times faster, to selenium, which is 200 times faster. So this is really important to know, because understanding the chemistry behind it and the biochemistry and the kinetics of this helps us to understand why these molecules are so important and what we need to be taking in our body and our diet to support ourselves when it comes to immunity. To manufacture enough GPx, we need to get a steady intake of selenium in our diet. And can anybody guess which country in the world has the lowest levels of selenium in the soil? And the answer is we're sitting right on it right now. New Zealand has the most selenium deficient soil on the planet. So selenium deficiency is a big problem, particularly in New Zealand. When we have deficient selenium, we don't make enough GPx. And when we don't make enough GPx, we can have all sorts of problems occurring as a result. So peroxide excess in the thyroid can occur, which can lead to hypothyroidism. And we do have increased levels of thyroid issues in New Zealand compared to other countries. So there's definitely a link there. It leaves us open for increased oxidative damage, weakened immunity, impaired self-recognition with autoimmunity, increased cancer risk. And to give you an example of how important selenium is, when we were researching the effects of these kinds of oxidants and antioxidants, we did some studies with what we call GPx knockout mice. So in this clinical setting, they had been able to produce these mice that were unable to make GPx. So they had no gene for GPx coding. Now, when these mice were born, they were incredibly sick and they wouldn't live long at all. And they had to irradiate the food of the mice. So any bacteria, any virus, anything within that habitat of where that mouse was living would kill that mouse. So you had to treat them incredibly carefully. Like they basically lived in a bubble that was disinfected every day. And the reason for that is because they weren't able to make GPx. And GPx is the most effective tool that our immune system has. So the reason I wanted to put that up is because I wanted to show you what the world would be like if we didn't have GPx in our body and we weren't able to take selenium and convert it into these protective enzymes. I'm going to come back to this because I want to detour into COVID and what is the link here, and why is people suddenly talking glutathione and cysteine and N-acetylcysteine? And it makes a whole lot of sense once you understand the mechanisms behind a COVID infection, because this is quite a different virus to what we've seen in the past. It's not like influenza. And the reason for that is because it's how it binds to the body is what creates the difference in the inflammatory response. So the typical infection process when it comes to COVID is, a 1 to 2 week incubation period, followed by, 1 to 2 weeks of viral isolation and immune response. And then by the sort of 3 to 4 weeks, we're starting to get what we call that innate immune response. So remember, that's the targeted approach where we've produced antibodies and we're able to isolate more rapidly and strategically kill that virus. So that the initial few weeks before the symptoms come in, and when the symptoms come in, is what we call the innate immune response. And that is where, like I said, the tanks and the guns all come in and just start shooting up. Let's look at what happens in this process, because understanding this is going to really help you understand where, glutathione fits into this thing. The binding site of the SARS-CoV-2 virus is what we call the ACE2 receptor. It stands for angiotensin converting enzyme receptor. So this is the receptor in which the virus attaches through that spike protein and injects itself into the cell. Now, there's a big problem with the virus binding this, is that it changes the biochemistry of our cells in what we call the renin-angiotensin system. So let's look at the role of this receptor in normal physiology. The normal role of this receptor is to convert, so it binds hormones from our body and it converts what we call angiotensin 2 into angiotensin 1,7. Now, this conversion is really, really important because angiotensin 2 is a highly inflammatory molecule. And what it does is it constricts our blood vessels, it increases sodium reabsorption in the kidneys, it ignites inflammation, and it starts to oxidize our blood vessels, our vascular system. When we start getting too much of this going on, our body sends in the hormone to bind the ACE receptor, and we start getting conversion of this. So it's like a seesaw. So it's in homeostasis and balance. And the conversion causes the angiotensin 2 to be converted to angiotensin 1,7. And then suddenly the blood vessels open again. We reduce down the inflammation levels. Our blood vessels relax. We get increased production of things like nitric oxide, which smooth out our blood vessels. And we're back into that parasympathetic mode. Okay, so these two molecules, angiotensin 2 and 1,7, are constantly kind of seesawing back and front. And what happens when COVID comes in and binds this receptor is it blocks that pathway because the receptor is now bound to the virus. So what we see happening is we start to see that seesaw that was balanced before go boom, like this. And we get this big buildup of angiotensin 2. And with angiotensin 2, we see an increase in inflammation, a massive increase in inflammation. And we can no longer get enough angiotensin 2 to 1,7. So we're out of balance with that seesaw. Now, as angiotensin 2 starts to increase, we start to get production, like I said before, of reactive oxygen species. So remember at the start when I showed you guys, this is our innate immune system and its tanks and guns, and here's the ammunition. Well, the ammunition is reactive oxygen species. And what we're seeing with the SARS-CoV-2 virus is we're seeing increased angiotensin 2 leading to an increase in superoxide and reactive oxygen species. So this is the ammunition that I was talking about that we want to protect our bodies from. But as the virus binds, we get this big increase in it occurring. So it's a highly inflammatory problem that we need to sort out. Now, as the immune system identifies, hey, there's this invader there, and they send in those tanks and those guns and they start bombarding with all of those oxidants, we start to see an increased production of these types of molecules because of the immune response. So whereas before we had this beautiful balance of angiotensin 2 and 1,7, we suddenly go boom, disbalance, increase in reactive oxygen species, and then the immune system comes in and starts blazing away and bombarding with more reactive oxygen species, and we see this problem of what we call chronic inflammation going on, damage to the cells of the blood vessels, and then we get this increase in these molecules called cytokines, which are inflammatory, pro-inflammatory molecules. So you may have heard of that term cytokine storm, but that's what we call this process. But this is what happens in the blood vessels. So most of the ACE receptors are around our lungs, our vascular system. They're in all different organs, but we see the biggest damage to our blood vessels. So this is a schematic of what our blood vessel looks like. So you've got the blood flowing down the middle. You have what we call endothelial cells, which are the cells that protect our blood vessels. And as we get this really big increase of superoxide occurring, and we start losing that inflammatory balance, we start damaging these endothelial cells. And then these things will start to clot and form these platelets and blood clots. And this is in essence why people get severe complications with COVID, because the blood clotting prevents the oxygen intake into the lungs. If I want to summarize this process in a few key steps, we have our SARS-CoV-2 virus. It binds that what we call the ACE2 receptor. We lose balance between our angiotensin hormones. We get an increase in superoxide forming. We get damage to endothelial or blood vessel cells. And then we get what we call thrombosis or blood clotting occurring, which blocks and creates a lack of oxygen to the lungs and the cells. Now, to give you an example of how impactful this can be on our body, in an average year, so 365 days, we will naturally produce superoxide around 1.3 kilograms per year. Okay, so 1.3 kilograms per year. Now, for a healthy person, that is completely normal and fine. And our antioxidant defenses, our glutathione peroxidase, will just slowly remove it out, no problem, and it won't impact us. When COVID infection occurs, that amount of 1.3 kilograms of superoxide, instead of having that in 1 year, you can get that amount within 1 to 2 weeks in your vascular system, depending on the viral load of infection and how much your immune system reacts to that infection. So that gives you an example of, you know, why for some people this can be a little bit difficult on the body, because if you're already struggling with vascular issues, and then you're loading up a year's worth of vascular damage in 2 weeks, it can be incredibly hard for the blood vessels in the body to cope with that. And that's why, you know, there's things that we need to look at that we can do to help support the body through that. Well, let's look at the role of glutathione, because glutathione is really one of these shields or one of these paramedics that comes running in to support damaged or disrupted cells or tissue, or to block, you know, block the ammunition, which is those reactive oxygen species. Well, this is what happens in a normal, healthy person. So we have superoxide, which leads to that damage to our blood vessels and increased cytokines. Now, superoxide is naturally detoxified via that enzyme I told you about, superoxide dismutase. So superoxide dismutase comes in different forms, but the main active areas or components of this are zinc, copper, and manganese. So this is why zinc is incredibly important in our immune system. Enough zinc will give you enough superoxide dismutase, and we can reduce down that superoxide. So superoxide gets reduced by superoxide dismutase, the enzyme, to peroxide. So any of you out there who have ever dyed your hair blonde, you would have used peroxide before. It's also a cleaning agent. It is itself an oxidant. So we're not out of the woods yet. We have removed some of that inflammation from superoxide, but we still have peroxide now to deal with, which can also be damaging to our cells. And this is where glutathione peroxidase does its job. So glutathione peroxidase, that selenium enzyme that I told you about, removes the peroxide and makes water. And now we've eliminated the inflammation. So this two-step process is basically like, you know, a tank standing in front of the enemy, ready to bombard, these two enzymes coming running in and putting up shields to protect all the civilians and the buildings around. And then as that tank unloads, these enzymes take the brunt of that attack. And within 2 steps, we can remove that inflammatory molecule that was intended to kill that virus. Now, as glutathione peroxidase, or GPx, does that, it loses its activity because it oxidizes. And the key thing to the recycling of this is glutathione. So glutathione is what we call a cofactor. It's a sulfur-based molecule. And what it does is it takes that glutathione peroxidase and it recycles it back. And it itself is then oxidized. And it gets reduced from glutathione reductase, which is another enzyme. So this system here of SOD, we call superoxide dismutase, SOD, GPx, and glutathione, are the 3 key components of protecting cells from all inflammatory damage in our body. And they rely on zinc, copper, manganese, selenium, and sulfur. So those are the 5 elements that are the most important when it comes to our immune response. And if we have enough glutathione, then we can just keep going. So this system just keeps going and going and going, and they will go around the body, through the vascular system, through the cells, and they will just keep protecting and regenerating. Now, a huge amount of the activity of this occurs in the liver. And if we look at the levels of glutathione everywhere in the body, the liver has almost 100 to 1,000-fold levels higher than everywhere else. And that's because glutathione is an incredible detoxifier. And the liver is where all the detoxification happens. So if glutathione is amazing, are they using it in hospitals? Are they using it for COVID? And the answer is, of course they are. Where I've got a lot of incredible information throughout the pandemic from is this YouTube channel here called medcram.com. Now, I've been on Medcram for years. Medcram is a lecture series for medical students to help support them through med school. And we used to use it all the time as a resource when I was doing biomedical chemistry. So it's not new. It's not like I've got onto Medcram just because of the pandemic, but during the pandemic, it's had some incredible, you know, 30, 60-minute long videos on there about all sorts of different topics. And they've really delved deep into some of the info surrounding the pandemic and natural treatments and all sorts of things. So it's run by Dr. Schwott, who's the founder of Medcram. He's a associate clinical professor at the University of California. And he's on the internal medicine board for the American Internal Medicine Association. What he takes, what he recommends patients who come down with COVID, not sick enough to be hospitalized, take vitamin C, vitamin D up to 400 international units per day, quercetin 150 mg per day, cysteine 500 to 1,000 mg per day, 8 hours of sleep a night, potentially 3 to 5 mg of melatonin, no more than 40 mg per day of zinc. And he talks heaps in this episode about hypothermia during the initial innate immune response and the importance of that. So I'm not going to go into details on that, but during days 1 to 7 of infection, and also that if you need a pulse oximeter and how to measure oxygen saturation and, you know, what to look for. But within this as well, you know, he discusses the innate immune response, how important the viral load is, so how much of a load you get of the virus initially, because that's directly linked to your outcomes, and a huge amount around glutathione. So they use in their hospital intravenous glutathione for patients, and there's a lot of amazing studies coming out now about the use of glutathione to support this. So when it comes to evidence surrounding glutathione, I've got some studies here that, you know, I think are really compelling. But what we know and what we've seen throughout the pandemic is that glutathione deficiency is an incredibly likely cause of serious complications. And it's quite interesting because I read, you know, we were all told, okay, it's, you know, people with heart disease, with diabetes, with vascular issues, you know, these are your high risk people, elderly people. And in all of those cases, they are glutathione deficient. But some of the interesting things that you know, that I've seen online relating to young people having severe complications with COVID, people that shouldn't have severe complications, and people say, why did he get sick? Or why did she get sick? But there's new evidence coming out now to support that it could be from glutathione depletion due to overexercise. And exercise actually can deplete glutathione reserves by up to 80% within half an hour of extreme exercise. So these kind of studies are really interesting. And when we look at this as well, men are 2.4 times more likely to die from COVID than women. But men consume glutathione much faster than women because of testosterone levels being much higher. So testosterone increases what we call lipid peroxidation, and glutathione levels for men fluctuate a lot more than women. If I'm a young male and I go and exercise vigorously, my glutathione, like I said, could be 80% deplete within half an hour. So if there are gym junkies and extreme athletes out there and they're over exercising, they could actually be at high risk, you know, for issues with glutathione if they're not supplementing and supporting themselves properly. So it's not just about old people. So there's really strong evidence, and there's a paper here that was published in 2020 about the rationale of supporting glutathione in COVID for prevention and for treatment. Let's look at this. Glutathione deficiency equals high risk. And who is at high risk for being glutathione deficient? Those with diabetes, insulin resistance, those that are smokers, those with high cholesterol, high blood pressure, elderly people, obese people, potentially people that are over exercising as well, all lead to glutathione deficiency, which increases oxidative stress. It means that we don't have enough glutathione to recycle out enzymes like glutathione peroxidase, and it leads us to increased risk of endothelial dysfunction and more severe outcomes when it comes to COVID. So my advice and the advice of the, you know, the people in MedCram and physicians out there is glutathione is an essential part of the way in which we can prevent and support our body as, you know, through this pandemic. So NAC itself stands for N-acetylcysteine. And now N-acetylcysteine is a form of cysteine in which this here is our cysteine amino acid, and the N stands for acetyl is this group here. We call an acetyl group that's been put on our cysteine. N-acetylcysteine has a long history of use both in the natural health industry and in the medical professions. It's actually indicated and it was has been used for 30, 40 years as a treatment in hospitals for paracetamol overdose. So NAC is here, and what NAC can do is three things. Firstly, it can be deacetylated to cysteine, and cysteine is then converted to glutathione. So it's a precursor to glutathione itself. It also can act as a disulfide bond-breaking agent, which gives it some mucolytic properties, so it's good at helping break down mucus, and itself can act as a shield, as an antioxidant. So it really has three different modes of action. And NAC is something that is very easy to produce, easy to manufacture. So it's become used a lot in the natural health industry, particularly as a precursor to glutathione, which is where most of its activity is come from. So what they've shown is if you supplement with between sort of 600 to 1,000 milligrams per day of NAC, your NAC will be ingested, it will be taken to the cell border, it will be deacetylated, and then uptaken to form glutathione, and your glutathione levels will increase. So that's really the rationale behind NAC and what it does. Now, what happened is that back when the pandemic started, a lot of physicians out there started looking at using glutathione in hospitals, using NAC in hospitals, And this led a lot of interest and review from the FDA into how this compound has been used previously, and how it should be used in the future. And what they review showed from the FDA is that because of its previous indication for paracetamol use, it came into that gray area of, is it a pharmaceutical agent or is it a natural product? And it had always been used in both. So like I said, it sat in that sort of gray area. So the FDA went to regulate NAC and to remove it from that natural product, natural health industry area, because their claim is that it had pharmaceutical indications, it's an in-hospital drug, and it should become only a prescription medicine, not a free natural product that can be used in supplements. So that happened last year. And then in New Zealand, MedSafe followed this year that approach. It's now not possible to capsulate a supplement in New Zealand containing NAC. And what I think we're going to find is, as we progress into the future, it's pretty much going to become impossible to get NAC in a natural supplement without being, subject to that interest from, organizations like MedSafe here in New Zealand, which is an incredibly disappointing, but it's not the end of the world, because NAC is only one way in which we can build glutathione. So what we're seeing is, because of this change in regulation, we're seeing a big increase, and suddenly people are going, oh, what's this thing that's being taken off the market? I want some, where do I get it? Because it must be good if they're taking it away. Well, the reality is, like I said before, there's many, many different ways that we can build glutathione. And what we need to look at is the big picture. And the big picture here is that NAC, in a natural supplement perspective, acts as a precursor to glutathione. That is where it's always been used, and that is where it's most effective. So taking NAC by itself as a single component can help build glutathione, but it's not necessarily the best way to boost our immune system and to protect us from viral infection and recovery. So let's look at how we produce glutathione. And what we know, well, what I know as a specialist in this area, is that there are many different ways that we can make glutathione. And the key important component to all of this is getting cysteine into the cell. There's other components that have been used and well studied, N-acetylcysteine or NMC. And this is similar in structure. Instead of having an acetyl, we have a methyl hydrochloride salt. N-carbamylcysteine or NCC is another one here, which is a natural product which has been used and shown to be used before to produce glutathione. N-cysteine hydrochloride, which is a hydrochloride salt of cysteine. And then we have some of these more interesting complex guys like S-allylcysteine or SAC. We have D-ribosylcysteine or DRLC, and this is another component which has been shown to be really effective at raising intracellular levels of cysteine and glutathione. Cystathionine, and then glutamylcysteine. So there's 8 examples of incredible molecules that all have the ability to raise glutathione levels in the cell. And what's really interesting is, the focus has all been on NAC, and that's because NAC is the cheapest of all of these. Not to say that, it's cheap, but it's the cheapest of all of these compounds. But it's been the one that's been most researched because of that indication for a paracetamol overdose. But new research coming out now, for example, where they've looked at some of these other precursors, has shown some incredible results. And what we've seen, and I saw one study recently that showed one of these cysteine precursors was able to increase glutathione production and levels by 4-fold more than N-acetylcysteine itself. So the research is going to obviously go heavily into this area from a natural health perspective in the future, because people are going to look for alternatives. And this is why, as a producer of natural products, I honestly believe that instead of trying to fight the system, if they want to take away NAC because it has a pharmaceutical indication, I can give you 9 other products that don't have a pharmaceutical indication that in some cases have better cysteine uptake, higher production of glutathione, that we should just use instead, and we should embrace and change and move with that change, as opposed to trying our hardest to try and find NAC via some website online and trying to order it internationally into the country, because I feel like over time it's just going to become more strict and more of a problem. And the last thing that we want to do is invest in trying to get a form of NAC into New Zealand and then having it blocked at the border, or losing a whole, or having to take it off the shelves and demarket it. Whereas I truly feel, having worked with glutathione and GPx for many years, the best solution is to advance the research and look more at some of these more effective ways of producing glutathione and increasing glutathione in the cells. So I want to put up a slide to show you how complicated this process is. This slide here is what I call the production of glutathione and the glutathione metabolic cycle. And I'll take you through it bit by bit. Over here on the left side, we have our form of cysteine delivery. So whatever this will be, it could be N-acetylcysteine, it could be methylcysteine, it could be allylcysteine. The cysteine delivery component of our supplement needs to get to the border of the cell. And when it's there, it needs to be easily converted to cysteine. And then the cysteine, when the gradient of cysteine outside the cell is high enough, it will be pulled into the cell via a transporter. So cysteine is the oxidized form of cysteine, which is also another way that we can get it into the cell. Once it's in the cell, it then has to be combined with glutamine. And also we use folic acid, riboflavin, vitamin B12, betamine, and methionine to form homocysteine, which combines with serine to form cystathionine, which will then assist to produce cysteine and glutamate. And once we've got all of this occurring, then we make glutamylcysteine, which is the other precursor. Now, glycine comes into the mix here and gets uptaken into the cell, and these two get combined. And with the aid of our liver cells, our hepatocytes, we can then convert it all to glutathione. Once it's in the form of glutathione, this will go to react and activate our glutathione peroxidase, which is where our selenium comes into it. And then as it's oxidized, it will be reduced back down with riboflavin and glutathione reductase. Now, the key part of this cycle also we've shown is that using things like lipoic acid and ascorbate, we can increase the activity of our glutathione in its reduced form. So quite a complex schematic when we look at it. Now, yes, you can have whole glutathione be uptaken into the cells, but the most important factor and the rate limiting factor is this step here of cysteine being uptaken. So the question is, if we only use NAC, are we making enough glutathione and are we supporting our entire system? And I answered this question when I was doing my own research. And when we bought out our initial GPx Cell Protect, our answer to that is no. It needs to encompass everything. If we don't have enough glutamine, if we don't have enough B12, enough methionine, if we don't have enough selenium, if we're not using things like lipoic acid and milk thistle to activate the liver, if we don't have an active cysteine delivery molecule, then all of this falls apart. So as a medicinal biochemist, you know, understanding the big picture is really important when we design a supplement. And what I say to people out there is there's no, I mean, there is benefit to using NAC by itself, but there is so much more benefit to creating a comprehensive approach to building glutathione. People have asked, you know, what would we recommend? If we're looking at protection during the innate immune response, preventing severe complications with COVID, recovery, which is a really big thing as well. Remember, if we're getting a year's worth of oxidative damage in 2 weeks, it can take the body a little bit of time to recover from that. So this is about prevention, managing, and then recovering. I would strongly go along with the recommendations of the MedCram lecture series and what they're doing in hospitals and physicians in the US, using vitamin D up to 400 international units per day during infection. We're lucky we're in summer at the moment in New Zealand. We need to get outdoors and get our vitamin D active. But as a maintenance dose, you can have maybe 1,000 units per day. But during infection, you would go higher. Vitamin C is really important. Getting cysteine and glutathione build up. Selenium is essential, and I talked about that because of its role with glutathione peroxidase. I'm a big promoter of using lipoic acid because it's a glutathione booster, and it helps reactivate glutathione. Zinc because of its role in superoxide dismutase. And something that I haven't talked about is crocetine. Now, crocetine is a very interesting molecule. It's been heavily researched with things like Ebola, is that crocetine as an antioxidant in itself, so it acts as a shield to help protect us, but its incredible role is what we call a zinc ionophore. And what this means is it has the ability to grab the zinc and pull it into the cell. So it acts like a channel to increase intracellular zinc, which can help enhance the activity of things like superoxide dismutase. So crocetine is something that we see is incredibly important in an immune response. Now, what's really interesting about this is, like, I've put this information up here based on, what the physicians have been using as natural products in, around the world with COVID. But 5 years ago, when we started the company, I had 5 of these compounds plus milk thistle and glutamine combined together in a supplement called GPx Cell Protect. And this supplement was specifically designed to help support people with chronic inflammation and vascular damage. And what we're seeing now is that this is exactly the combination that you'd want to be using with something like COVID, because it's a vascular infection. So the reformulated version of this, it used to be called GPx Cell Protect, is now GPx Immune Protect, and it's really specific for immune function. So what we've done with this formula is, like I said before, it's for boosting your natural levels of glutathione and GPx. It protects your GPx from becoming inactive. It increases the absorption and production of all those components. So that big complex schematic that I put up about glutathione, we've got every angle covered. And it also is a mucolytic that reduces oxidative stress. So we've got an incredible, so we've changed our selenium from what we had before. We've got this amazing new organic form of selenium. We've used a really exciting new cysteine delivery system, which in clinical studies was shown to be 5 times more effective at getting cysteine in the cells. And this is why I want you guys to start thinking, stop thinking about NAC and start thinking about glutathione, because what is the purpose of NAC is to build glutathione. And if we can find more effective ways to support and build it that are going to give us better clinical outcomes, then we're not subject to the issues with trying to deal with MedSafe and deal with the regulatory bodies. We need to adapt and evolve, and we need to move forward. And I think the research is super exciting, and there's so much that we've got coming out that we should be focusing on. So we've also got glutamine, which, remember, is the key component to form that glutamyl cysteine. We've got lipoic acid, which helps build glutathione itself, but helps recycle and activate it. We've got ascorbate for gut absorption and also glutathione activation, milk thistle to detox and cleanse the liver, and we've upped our crocetine amount. So with this new formula, we've now got 40% higher active ingredient with our cysteine. So we're up to 1 gram now, whereas we used to do, I think, 70 or 700 milligrams. And it's a more effective form of cysteine that will increase cellular uptake. So this supplement is really specifically about viral infection and immune support. And we're moving away from more where it used to just be ongoing vascular support, into a more specific supplement that can help with prevention also during and then post recovery, because we see this as being something essential to the long-term strategy to natural immunity that we're all going to need as this virus becomes endemic. The last thing I want to see is people out there suffering with long-term COVID or long effects of COVID, or flare-ups or exacerbations of inflammatory issues. You know, and I honestly believe that supplements like this can really help support us. So, you know, think about prevention, think about during, and also think about after as well, and the way we can rebuild ourselves. If you're new, here's some dosing information. If you're new to glutathione, if you've never had glutathione before, we would say 4 caps per day for a minimum of 6 to 12 weeks. It can take up to 3 months to build glutathione. So we really want to get people on a decent dose for 6 to 12 weeks and get their glutathione levels up. If you're gone through, if you're not new to glutathione, you've done it before, you know, 2 caps a day can be a maintenance dose. It's perfectly fine and healthy. Now, remember some of those things. If we have, you know, inflammatory flare-ups of any sort of autoimmune conditions, if we have any infection, we want to be upping our dose. If we have a lot of exercise or over-exercise going on, you know, you want to be upping your dose. When I'm surfing regularly, you know, I take much higher doses. If I surfed, I think in the last week, about 12 hours. And, you know, during those recovery days, I'm going for, you know, 4 to 6 caps per day to try and get my glutathione levels up, because I don't want my immune system to be down just in case I encounter a viral infection or any infection. So during infection, you can go to 4 to 6 caps. Now, don't go above 6 caps. Really important. Also that you check other supplements you're taking. If you have a supplement that contains selenium, you cannot double up. We've given you a maximum dose of selenium. You're up to 150 micrograms on 6 caps. You're up to just over 200 micrograms. If you take too much selenium, it actually can be toxic on your body. So really important that you check. If you have selenium in another supplement, do not combine the two. Post-exercise, 4 caps per day. Maintenance dose is 2 caps per day. If you're children or younger, we would go with 2 caps per day. And pregnant or breastfeeding, we would say, firstly, you know, consult with your healthcare professional first before taking any new supplement. But if you are going to use it during that, then 2 caps per day would be the advice, so not going for a high dose. We've got our pricing here. So we're doing $89.90 for a full 1 month dose, but that can be also 2-month maintenance dose. And we do a 3-bottle special, which is on our website. So that's 12 weeks, which will give you, if you've never had glutathione before, that'll give you your 12-week dosage. And it's all available at our shop, selenohealth.com. Yeah, if you guys have any questions, I mean, we've been using this supplement. You know, we've had people using it for the last 5 years. The new improved version is really focused on immunity. It's higher dosing. It's better absorption, better uptake, better glutathione production and recycling. There's different dosing that you can take. So, you know, for most people, 2 caps a day is probably going to be enough to maintain. And we truly, you know, believe that it's an all-in-one that you need. You don't need to go out and buy, you know, 5 different supplements. So, you know, there's definite advantages to using it. And we've already seen some incredible results, like I said, in the US, in Australia. Our whole team in Australia got COVID when Omicron spread. And thankfully they were all okay. But with regards to recovery, they have recovered incredibly well. Our sales rep, my brother who's over there working with the company, using really high doses of this supplement. So we're super excited about having it available in New Zealand. And yeah, and hopefully we're going to have enough stock to get you guys through, because that was our problem last time, was it was so popular we were selling out. So I'm going to finish with a summary, and then we're going to get into your questions. When it comes to supporting natural defense, and like I said before, like, let's look at this. When we're looking at immunity, you know, I'm talking only about the innate immune response. And that is the response of the all guns blazing, identifying that there's an invader and just shooting all the ammunition that we've got. Now, that can lead to serious collateral damage to our cells, which is what we see, you know, with COVID, and it's a very inflammatory infection. So what we are trying to do with natural protection is provide shielding to prevent this collateral damage, to give our immune system time to eliminate the virus without destroying our own vascular system, and also provide support to the damaged cells and tissue so that we're not killing those cells off. So we can do that through the food that we eat, and this is why diet is incredibly important. Like, it's not just about taking a supplement, it's about eating the right foods day in and day out. We can do it through lifestyle changes, through sleep, through sunshine, through working on our mental health, mindfulness, breath, supplements, and you know, all sorts of other ways. So it's an all-in-one holistic approach. But what today I really wanted to focus on was all these questions surrounding this part, the protective enzymes and molecules. We have these incredible molecules and enzymes like superoxide dismutase, glutathione, glutathione peroxidase, and all of them go to support and protect our cells in terms of, you know, this shielding and this recovery and reducing down that collateral damage. So I hope you guys have learned a little bit about selenium and sulfur and how incredible they are, about zinc, about some of these amazing enzymes and what they can do. Remember that the activity of them and the protection is based on their concentration, their ability to recycle, and their speed of oxidation. And then when it comes to building glutathione, which we know is a direct indicator of outcome for COVID, you know, we can do it through all of these lifestyle things, but through supplementation, we need cysteine delivery to the cells. We need other components like glutamine to help build it. We need to detoxify the liver through things like milk thistle. We need also adequate levels of selenium, which is incredibly important to get our GPx firing as well. And then with that, some of those things like lipoic acid and other cofactors to help recycle are really important. So it's not all the end of the world that NAC has been taken away. I've given you 9 other examples of molecules that are as effective or more effective than NAC, that are natural products that are potentially readily available. We've developed a supplement that contains one of those key components. We've shown that it is incredibly effective for cellular uptake, and we've created it in an all-in-one encompassing supplement that you can take, as opposed to buying all of those individual components yourself.